Welcome to Moon Trees Live 3.
The Forest Service provided hundreds of tree seeds to NASA, who launched them into space as a part of the Artemis 1 mission.
In this set of 3 videos, we're exploring what happens next with our tree seed friends.
In this episode, we're going to discover how we measure the development of our tree seedlings.
In case you missed our previous programs, check out Moon Trees Live 1 to learn about how these tree seeds were prepared for their journey through space. And check out Moon Trees Live 2 to learn about what happened to the seeds once they returned to Earth. Also, check out our first episode of Moon Trees Live 3 to see how our seedlings are growing in the nursery.
But today, let's talk about how we're conducting our experiment. Like any scientific experiment, we have our control group and our variable groups.
In an experiment, the control group are the subjects that are likely to have a known outcome. The variable group are the subjects that were exposed to something different that may or may not have caused a different outcome.
In the case of our moon trees, our control group were the seeds that did not go up into space. Then we had 2 variable groups of tree seeds that did go into space. One group was loaded onto the rocket months before it launched. We've been calling this group NASA 1 or N1. The other group was loaded onto the rocket just before it launched. We've been calling this group NASA 2 or N2.
Our basic idea behind the design was that we want to know what's going to happen to these seeds as they make their journey through space as compared to what happened to seeds when they don't go on their journey to space. So it's kind of like a comparison of basic differences, right?
We were also curious if there would be any difference between the seeds that sat on the rocket for months versus the ones that were placed on the rocket just before it launched.
Now keep in mind that seeds in the capsule aren't being stored under those optimal conditions like they are in the control group, where they're stored in a freezer under all these perfect conditions.
So that's why we designed our experiment this way. We have 2 questions we're trying to answer. Does space travel impact our seeds? And does proper long-term storage impact our seeds?
Now that the seeds are back from space, what we're doing is measuring the growth of our 3 groups. If our control group is growing differently than our variables, then that might mean those differences were caused by the space travel. If our 2 variable groups grow differently, then that might mean that those differences were caused by how they were stored.
So now we need to figure out how to measure that growth. One measurement is pretty simple. We just see how big they're getting.
How do you measure growth? Well, it's pretty simple, and we use these fancy scientific tools like this ruler. This is a Smoky Bear ruler, and this is actually a ruler that I use to measure seedlings for my experiment. They're small, right? So we don't need a big ruler, but we just stick that into the next to the ceiling and tally the height in centimeters.
So we measure their height, but we also want to measure their diameter. The diameter is the distance from one side of their trunk to the other. Basically, this lets us know how wide they are. And we measure that using something called digital calipers.
So this is a pencil, but this is a digital calipers that we use to measure stem diameter. And so we'll take this as an example, and we'll just take this caliper and you measure the diameter of the stem.
The trees are eventually going to get so big that we can't measure them with calipers because they won't fit around the tree trunk.
So we're going to switch to some good old-fashioned measuring tape. We typically measure trees by taking their diameter at breast height, or DBH. That's just a fancy way of saying that we measure the diameter of the tree from about chest level.
It's all simple so far, right? We're just measuring how fast these little guys are growing. But we also want to know how healthy they are.
Plants feed themselves with a process called photosynthesis. Photosynthesis is the process where plants use sunlight to turn carbon dioxide and water into food. They need to do this in order to survive.
So we want to know how good our moon tree seedlings are at photosynthesis.
We get a little more complicated in our equipment that we use for that. And I have this thing here, we call this a gas analyzer. This is a specific machine that measures carbon dioxide, it measures temperature, and it measures water. This opens up like this, and let's say this was a moon tree leaf attached to one of the seedlings. I can actually clamp onto a leaf, and this machine will take a measurement to see how much carbon dioxide that plant is using. And so this is really cool. It's a real active live time series measurement. And I can clamp onto those moon tree seedlings and say, okay, did that space journey have a subsequent effect? And some of those trees aren't allocating carbon quite as good as the other ones.
You might be wondering what Jeremy means by allocating carbon? Well, we mentioned that when plants go through photosynthesis, they use carbon dioxide. Carbon dioxide is a gas made up of carbon and oxygen. What do plants do with the gas when they're done with it? The oxygen just gets released and is actually what we breathe. The carbon, though, gets absorbed into the plant and they store it.
This is great because that keeps extra carbon out of the air. So when Jeremy is checking to see if some moon trees are allocating carbon better than others, he's looking at how much carbon they're storing. He's really measuring quite a lot.
So we're taking all of these measurements and we've designed our experiment to get the most accurate results possible. We believe in following the goal of the Next Generation Science Standards, or NGSS, which is to plan and carry out fair tests in which variables are controlled and failure points are considered to identify aspects of a model or prototype that can be improved.
Because that's really the other point. Not only do we want accurate results, but we want to know what we can do better next time we send seeds into space.
So, what were the results of these measurements? Well, I hate to leave you on a cliffhanger, but we're going to talk about that in our next video. That's right, more Moon Trees Live 3 episodes are on their way.
In 1 week, find out if space travel had any impact on our seedlings. In 2 weeks, join us for a live question and answer program where our experts will answer your questions live.
Moon Trees Live 3, the journey continues. So be sure to join our all-star cast for more out-of-this-world adventures by checking out all of our videos.
Thanks for watching.
You have a range clear launch.
3, 2, 1.